For the second part of section 7.3, we are looking at something called the product rule. So this is for when you're finding a derivative and you're looking at two terms that are being multiplied together. So you can see right here we got a x to the third being multiplied times this trinomial here. So the way that we've seen that so far is that you would take this x to the third and you would distribute it to all of your terms, and you would get for this look here, and then you would find the derivative for individual terms. And that's a way to go for certain items, but there are some problems or some functions where either that's going to be just too much work and it's not worth it, and you need a shorter way of doing it. And then there are others where you cannot combine them together because you're dealing with different types of terms that just won't combine, and so you need a different way of finding a derivative sometimes when you're multiplying terms together. So that's why this one's called the product rule, because you're multiplying. So in another way of doing that, instead of distributing the x to the third, would be to do the rule that you're seeing here. So they're letting u represent the first term, so like we'd call this the u term, and they're letting v represent the second term, so what you see here in parentheses would be the v term. And so that's kind of how you're separating those out so that you can identify the rule. So what you're seeing right here with that rule is you're doing the first term times the derivative of the second term plus the second term times the derivative of the first. And you just follow that pattern. This one is in your formula packet. Most of the things for what we do with the calculus is in your formula packet. So that's something you should always be aware of. So here we are right here with the product rule. And so that's the one I just mentioned a second ago. So if you were to ever forget, this is a place you could go. Some other ones that we've seen already so far, this was in our last lesson for e to the x or natural logs. We'll be getting to some of these other guys later. But these are all in your formula packet, so something you should be aware of. So as we go through, so to take that approach on this function, instead of going for the distribution and getting those individual terms, let's apply the product rule so you can see what that looks like. So you have your first term times the derivative of the second term. And so that's what you're seeing right here at the first stage, is I have my first term, which was x to the third, times the derivative of the second term. So remember, if you use the power rule on this, the derivative, you'd be looking at 2x to the first plus 2, and your constant goes away. So there you go with the first term times the derivative of the second, plus your second term. So I keep the original second term times the derivative of the first. So right here you're looking at the power rule for this term, so 3x to the second, get you that second term. And so this is how it would look as it's all laid out. All you have to do at this point is simplify. So, and you do need to simplify. Don't leave it in this expanded form. You need to simplify it as much as it can go. So as you look at that first term, you would distribute the x to the third. On the second term here, you're going to distribute the 3x squared to all those terms, and then if you combine like terms, it comes all the way down to this look here. And you can see, compared to what we had up above, if we went for the individual terms with distribution, you get the same answer. This is just a different approach. This is probably one case where, yeah, it probably would have been simpler to just distribute the x to the third, but like I said, there's going to be cases where that's not the quicker way to go, or you can't do it that way. You have to be able to use the product rule. So it's best to just get in the habit and be familiar with the product rule for those cases where it just makes a lot more sense. So I showed you this method here. This is just another way of looking at it. So the u term, or the first term, times the derivative of the second plus the second times the derivative of the first. Though I would say it's more important to be familiar with this look here, because this is the one that's in your formula packet. So this is what you would get on the test. And so I would keep this one in mind moving forward. So here's just a few examples. And again, here's a case where I could go through all the distribution on this and lay this all out and distribute the x to all of those. I could distribute the 3 to all of those, combine like terms, and you could go through that process. But again, that's probably more work than is necessary here. So using that product rule, so here's our first term, x plus 3. We're going to multiply that times the derivative of the second term. So we're looking at the 2x minus 2. Drop your constant. So there's the derivative of the second plus the first term, or sorry, plus the second term. times the derivative of the first. So if I look at those parentheses, the derivative of this guy, remember this is just 1x to the first, so 1 times 1 is 1, x to the 0 is 1, and my constant goes away. So we just get a 1 out of that. And this is a pretty simple cleanup at this stage, so if you do some distribution on that or FOIL, and then combine like terms, we can get it all the way down to this look here. So again, do simplify as much as you can. Here's just another example using one of the new rules for e to the x. So again, if I were to do, and keep this one in mind, this is one where you really can't multiply these two terms together. You don't have common bases, so there's no way to combine exponents on this. So this is a case where you really need the product rule in order to get this proper answer. So if we do our first term times the derivative of the second, so here we are here with the first term times the derivative of the second term, plus our second term times the derivative of the first. And remember, the derivative of e to the x is e to the x, so that's the derivative of the first term. And now if we clean up as much as we can, because these both have e to the x in them, we can factor that out as a common factor. And this is what you would have left behind within those parentheses. If we wanted to, we could factor out more. These both have 3x to the third that could also come out, and so you could get this look here. I would say between this setup and this setup, arguably neither one of those is really simpler than the other, so either one would be accepted. Again, this would just be a case of, follow the directions. If they ask you for a specific look to your answer, then you got to do that, but otherwise I would say either this look or this look would be good. Another case right here, and again, you can pause at any time and give this guy a try if you want, but if I stick with my product rule and I have my first times the derivative of the second, so remember that the derivative of a natural log is just 1 over x for that case there. So you got your first times derivative of the second plus your second times the derivative of the first. Using that power rule, you get the 2x. And again here, if whatever could be cleaned up, try to do that. So right here I have an x that could be eliminated from each one of those, and that's what gives you x to the first. And then on the second term, no way to really combine those, so we would just have to leave it looking like this. And at this stage, again, you could factor out an x from each term to get this look here, but again, I don't know that you could really consider this to be simpler than this. It's just a different look, so either one would be accepted. Here we go. So just finding another derivative, some more product rule stuff. So I'm going to go a little quicker through these. This is kind of more of the same. So just remember that before you do derivatives, you don't really want radicals. You would rather see this as x to the 1/3 power. So that's a more friendly look. But now you could apply that product rule, or the product rule, and do your first here times the derivative of e to the x, which is e to the x, plus your second times the derivative of the first. And again, here's another case where formatting your answer is, it's a little questionable as to what is right or wrong. So go with what you feel would be the simplest look. In this case, these do have a common factor of e to the x, and so that's something that could come out of there. You don't have to put it back into radical form unless the directions would ask you to do that. So here's another example of that. And again, something with a common factor that could come out of there. So just simplify as much as possible. So now in these last couple here, tying in a previous concept with our new concept, we're looking for the equation of a tangent line. As soon as you see equation of a tangent line, remember you're thinking we want to use our point slope setup in order to get the equation of that line. So you need a point and a slope. So you got to take a look at what's been given to you and fill in what's missing. Only thing that I have is an x coordinate, so I'm still going to need a y coordinate, and I'm still going to need a slope in order to use point slope. So here we are with the x coordinate. You always plug your x coordinate into the original function to get a y coordinate. So if I replace those x's with 1s, so 1 to the third is obviously 1. The natural log of 1 is 0. Because remember, you're basically saying e to what power is 1. Well, anything to the 0 power is 1, and so that's why you get a 1 on that. So if you stick your 1 in for x and simplify as much as you can see our y coordinate right here would be 0. So here you go with your y coordinate, you got your x coordinate, the last thing you need would be your slope, and we always get that by subbing in an x coordinate into the derivative. So here's where we can apply the product rule here to find our derivative. So you got your first, x, which is x to the third, times the derivative of the second, and so that's what you're seeing right here within this work. So first term times the derivative of the second, plus the second term times the derivative of the first, and if you do a little cleanup on that, you come out with this look here. So that's my derivative. If I replace my x's with my x coordinate of 1, then I can get the slope that we need here. So if I replace those with 1's, again, here's if you simplify all that, this is what you're going to come out to. So because the natural log of 1 is 0, from here all the way to here you get a 0 plus 1 to the second. So that's where you get your plus 1, and so that becomes our slope. And now I can go through my point slope setup in order to get the equation of a line. So remember always on writing the equation of tangent lines to check your directions and see if they ask you for a specific format. In just about every case when you come to a test question, the directions are going to give you a specific format for your answer. So it could be in y equals mx plus b form like this one is. It could be in standard form like ax plus by equals c. It could be those different cases, and so you got to read the directions and make sure you format your answer properly. So here's the last one here. So this one is now asking you to find points on the graph, and so we're looking for ordered pairs for this last question. So here they're giving us a function, and you can see by the multiplication here that we're going to need a product rule at some point on this. So this one here, they're giving us a slope. So this one is saying that we have a tangent line of 0. So remember that a line that has a slope of 0 is a horizontal line. So sometimes this is worded as the slope is 0, or typically they would say the gradient is 0. They could also just refer to it as a horizontal line, and that would also tell you that you have a gradient of 0. So they could word it either way, but remember, if the gradient is 0, that simply means that the derivative is 0. And so I'm going to find the derivative of our function here, set it equal to 0 so I can solve for x. So using our product rule, right here you got your first term times the derivative of the second plus your second term times the derivative of the first. And a little cleanup on that would put you right here. So we factored out the e to the x, and I'm going to set the whole thing equal to 0 because of the statement that you see right here, and now we can solve for x. Anytime you solve an equation by factoring, we always take our factors, set them equal to 0 in order to get our solutions. But if I were to set e to the x equal to 0, that is not solvable. There is no number you could stick in here for x that would give you a 0 solution. The common response is for people to say, well, if I put a 0 there, then I'll get 0 as my answer. But remember, anything to the 0 power is 1, not 0. So I cannot get a solution from him. So we're going to look at our other factor here to get solutions from this guy. So if I were to solve that factor by setting it equal to 0, right here I can take out a common factor of x, and so that's going to give me the look that you see here. So if I set this factor equal to 0, so if x equals 0, that gives me one solution. And if I set x plus 2 equal to 0, I get my second solution. So I'm going to get 2 points on this one, and that was hinted at right here by the plural that they gave in the directions. So it said find the points on the graph, and so I kind of expected to come out with 2 solutions anyway. So these are my x coordinates, so all I need to go with them are y coordinates, and hopefully you've heard me say this enough times by now, but if I plug my x's back into the original function, I can get y coordinates to go with them. So if I plug 0 back in here for x into both those spots, I'm going to come out with 0 as a y coordinate to go with it. So that was my first point. And if I sub -2 in for x, so -2 squared times e to the -2nd, and you simplify all that, you come out with a y coordinate for him. And so those are the 2 points that we were looking for.